On this 2019 to 2025 Ram 1500 DT with the 3.6 Pentastar, P0325 points us toward the knock sensor 1 circuit. In plain terms, the PCM may not be seeing a believable signal from that knock sensor circuit. The driver may notice a check engine light, and depending on how the vehicle reacts, there can be possible drivability changes tied to spark control. Broadly, this can involve the knock sensor signal circuit, the sensor return circuit, connector or terminal problems, the knock sensor itself, or in the end, the PCM. Before getting into circuit testing, start with the basic system checks, and if other codes are present, check what they mean first. For this code, treat the running conditions as the monitor gate. The diagnostic runs with engine speed above 2000 RPM, battery voltage between 7.5 volts and 15.8 volts, and barometric pressure above 75.2 kPa. The PCM sets P0325 when knock sensor input voltage is above 4.8 volts, or when it is less than 0.2 volts with engine speed above 2000 RPM. So the diagnostic path is really about proving whether the signal is being pulled too high, pulled too low, opened up, shorted to another circuit, shorted to the sensor return, or shorted to ground. Start by scanning all ECUs. Record the DTCs and the related environmental data, and save a vehicle scan report and recorded data for reference on the job. Then erase the DTCs, turn the ignition off for a minimum of 10.0 seconds, turn the ignition back on, and operate the vehicle under the same monitored and captured conditions that set the code. Read the DTCs again. If P0325 does not return, handle it as an intermittent condition. If it does return, move into circuit testing. With the code confirmed, turn the ignition off and disconnect the harness connector at the component on the circuit being tested. Use the wiring path to stay on the correct KS1 signal circuit. Turn the ignition on and measure voltage at the component harness connector with a DVOM. On a 5.0 volt signal or reference circuit, expected voltage should be between approximately 4.8 and 5.2 volts. If the KS1 signal circuit is above 5.2 volts, continue by isolating the circuit and checking for a short to another circuit. If it is not above 5.2 volts, move on to checking the signal circuit for open or high resistance. When the signal voltage is above the threshold, turn the ignition off before doing resistance checks. Isolate the KS1 signal circuit by disconnecting the ECU and every component connector that contains that circuit. Leave the inline connectors connected at this point. At the ECU harness connector, put one DVOM lead on the signal circuit being tested, then probe the other circuits at that connector with the other lead. If you need to work at a PCM harness connector, use the Diagnostic 10436 adapter. With the circuit isolated, there should be no continuity between the KS1 signal circuit and any other circuit. If there is continuity, repair the short between those circuits, using the wiring path and inline connectors to help narrow down the location, then verify the repair. If there is no continuity, go to the related PCM and component connection checks later in the path. If the short-to-voltage check does not send you down the high-voltage branch, check the KS1 signal circuit for open or high resistance. Keep the ignition off for continuity testing. Disconnect the ECU and the component connector for the circuit, and use the wiring path to stay on the correct wire. Before measuring the circuit, measure the resistance of the DVOM leads so you know what the leads are adding. Then measure resistance from the component harness connector to the circuit at the adapter. The diagnostic adapter can add up to 1.5 ohms of resistance to the circuit. Do not probe the PCM harness connectors. Probing them can damage the PCM terminals and create a poor terminal-to-pin connection. Use the diagnostic adapter for this diagnosis. If resistance is below 3.0 ohms, continue to the sensor return circuit. If it is not below 3.0 ohms, repair the open or high resistance in the circuit, then verify the repair. Next, test the KS1 sensor return circuit the same way. With the ignition off, Isolate the circuit by disconnecting the ECU and the component connector that contains the sensor return circuit. Measure the DVOM lead resistance first, then measure resistance from the component harness connector to the circuit at the GPEC adapter. Again, the GPEC diagnostic adapter can add up to 1.5 ohms of resistance to the circuit, and the PCM harness connectors should not be probed directly. If the sensor return circuit is below 3.0 ohms, move on to checking for a short between the signal and return circuits. If it is not below 3.0 ohms, repair the open or high resistance, then verify the repair. Now isolate and check whether the KS1 signal circuit is shorted to the KS1 sensor return circuit. Keep the ignition off. Disconnect the ECU and every component connector that contains the circuit being tested, and check continuity between the two circuits at the component harness connector. If working at the PCM side is needed, use the GPEC Diagnostic 10436 adapter and do not probe the PCM harness connectors directly. There should be no continuity between these two circuits. If continuity is present, repair the short between the circuits and verify the repair. If there is no continuity, continue to the short to ground check. Next, check the KS1 signal circuit for a short to ground. With the ignition off, isolate the circuit by disconnecting the ECU and every component connector that contains the circuit being tested. Connect the negative DVOM lead to a known good ground. Then use the positive lead to check the signal circuit at the component harness connector for continuity to ground. Use the GPEC Diagnostic 10436 adapter if the PCM side has to be accessed, and do not probe the PCM harness connectors directly. There should be no continuity between ground and the circuit being tested. If continuity is present, repair the short to ground, using the wiring path and inline connectors to help isolate the location, then verify the repair. If there is no continuity, the circuit checks have not found the fault, so the next step is knock sensor 1. At this point in the path, replace knock sensor 1. Then reconnect the component and ECU harness connectors, turn the ignition on, erase the DTCs, and operate the vehicle under the environmental data or monitored conditions that set the code. Read DTCs again. If P0325 does not return, the faulty component repair fix the fault, and the next move is to verify the repair. If the code does return, continue to the PCM and related connector checks. If the code returns after replacing knock sensor 1, inspect the related PCM inline and component connections. Disconnect the PCM harness connectors, any related inline connectors if equipped, and the related component connectors. Inspect the harness connectors, component connectors, and male and female terminals for proper installation, damaged locks, corrosion, water intrusion, weather seal damage if equipped, bent terminals, overheating, discoloration from a poor connection, terminals pushed back in the cavity, spread terminals, and proper terminal tension. Repair any conditions found. Then reconnect the PCM connectors, inline connectors if equipped, and component connectors, making sure everything is fully seated and the locks are engaged. Erase the DTCs, test drive or operate the vehicle under the monitored and set conditions, and read DTCs again. If P0325 does not return, the wiring or poor connection problem has been repaired. If it does return, replace and program the PCM, then verify the repair. Keep the repair verification separate from the circuit testing. After any repair, clear the DTCs, operate the vehicle under the conditions that originally ran and set the monitor, and confirm the code stays gone. The takeaway on P0325 is simple. Confirm the code first, prove the KS1 signal and return circuits before condemning the sensor, protect the PCM terminals by using the proper adapter, and only move to PCM replacement after the circuit, sensor, and connection checks lead you there. For more diagnostic training, visit stepdiagnostics.com.